Test. please take your seats. We'll starting in a minute. Or if you can find any seats, then you can stay. Stand up. Please take your seats. Okay, that's fine. Okay, everybody sitting? Okay, last time for you to take your seats. And it's time for me to start the meetup. Today, we gather here to see, or hear, what low-level cloud-native observability is. Who are we? We are Zdeněk Váňa and Pavel Strobel, which is me, and Zdeněk Váňa is over there. We are Cloud Native Prague. We are organizing these meetups for over a year. This is 14th iteration, and we actually brought for you some merch. It's over there. There are T-shirts, stickers. You can take anything you want. And let's move on. Let's talk about Cloud Native Computing Foundation. We are like something like under the Cloud Native Computing Foundation. We are Cloud Native Prague, so you can hear that Cloud Native Prague and Cloud Native Computing Foundation is kind of similar. We are, thanks to them, we have a lot of resources, not so much, to use, but yeah, Cloud Native Computing Foundation is known for I'm not sure how to get it together, but yeah, for Prometheus, Kubernetes, and other software, mostly probably Prometheus and Kubernetes. Actually, Prometheus is still second most active project in Cloud Native Computing landscape. Yeah, what I said. What is CNCF? You can see it. There is 141 CNCF projects, which I pressed X stood out because I think there is much more. This is a little bit older presentation. You see Kubernetes, Prometheus, OpenTracing or OpenTelemetry nowadays, Fluentd, Linkerd, Jaeger, etc., etc. There's a lot of projects that are more or less known. And that's it. That's Cloud Native Computing Foundation. And as well, they made certifications for you that you can have. Okay, let's talk again about Cloud Native Prague. We have community page. If you open cloudnativeprague.cz, you will be at our CNCF webpage. We have like information about our meetups and events. Not only meetups, because one event per year is, I wouldn't consider it like meetup. We have Slack, you can join, you can ask there, you can network there. We have slides sometimes. We have records. I'm trying. You can involve, and if you want to speak, if you want to host meetup, if you want like anything else to help us, you can use involvement called nativeprague.cz. We have partners as well. Cloud Native Computing Foundation Bratislava, which is in Slovakia, is our partner. KCD, or Kubernetes Community Days, has been known. Actually, it was last month in Prague, and it was really a really nice event. PyCon, Prusa DevOps Meetup, DevOps Days Prague, and of course Golang Meetup, organized here by Láďa. Well, I would like to thank Prusa Research for all this space, not only space but catering as well, and for like projector cameras, etc. Everything. Really appreciate them. Okay, first speaker is Richard Hartmann, and he will talk about philosophy of observability. Second speaker is Sebastian Schubert. He will talk about cloud-native observability for physical infrastructure, so that's why low-level cloud-native observability. And this is Slido. Or no, this is QR code. This is not Slido. But you can scan the QR code and open the Slido, or just open Slido, slide.do, yes, and put CNP14 there, and you will get the page where you can ask. Of course, you can ask in person, but we prefer this way. There's also a link there. And last thing to tell, there is toilets, there is beer, there was food, there is water, there is glass. That's it. And yeah, and after event there will be obviously networking, and there will be quick tour around the company. You can attend if you want to. Okay, thank you.
The good thing about being in Prague is I'm allowed to drink beer while having my... Is this loud enough? Because I think this is less loud as the other microphone. Is this okay, or do we need to make it louder? For the people in the back? Louder? Okay. Or can I just have yours? Pavel? Can I just have yours? Yeah. Oh, this one is...
Hello?
Oh yeah, that's way better. Better for you in the back? Okay, cool. In theory, I have slides if you want, but I prefer to not do them with slides. The reason is I actively want you to interrupt me. Like, I mean, I'm going against the guidance with the Slido thing, but whatever. Like, the explicit point here is, yes, I can stand here and talk for an hour about stuff. If you want me to, completely fine, I can do that. But at the same time, I want to always be very conscious about where do people want to go, what is of interest to the local crowd. So anything which is interesting, anything you have a question on, feel free. Only ask us if it's more of a statement, less of a question, do it more of an after, not during, because that eats into the time of everyone. So, philosophy of observability. Let's start with, and you'll notice during the thing that I like to think about stuff from really first principles and like a lot of social things. Observability is absolutely 100% a buzzword. And a lot of people are trying to sell you old stuff with the new name, or do old stuff at the company and give it a new name and hope for a raise just because they call it a different name. Like, this is more or less the definition of a buzzword. And you always have a little bit of a kernel of truth in a buzzword, because there is a reason why the thing became initially successful, but also it lost some of its edge and some of its definition. One thing which I like to think about, or one thing which I always have in mind when talking about buzzwords, is cargo culting, which is a term which was coined in the Second World War, where Pacific Islanders observed people coming onto their small islands, and they started to clear the forests. They started to build strips of land. They put up light towers, and they did little marches, and they did all kinds of weird stuff. And all of a sudden, the gods started sending gifts from heaven and over the ocean. obviously those were soldiers and they were spearheads, and then for the war effort, cargo planes came and cargo ships came and supplied the war effort. But even though to this day, even though today the Pacific Islanders obviously understand the dynamics of how does a ship work and how does a plane work and everything, still they have proto-religions in those regions where they do little marches, where they do build small lighthouses and everything. My point here is the following. This dynamic of observing behavior and then observing success and having little to no understanding of what happened in between is very, very deeply ingrained into the human psyche. So I'm explicitly not saying it is a bad thing to try to run after a buzzword, because a lot of those buzzwords actually have value. But it is very much about the in-between. The success is almost the boring part. It is important to understand how other people and why other people have been successful in what they did. If you want a scientific definition of observability, it's super easy. Observability is the extent to which you can determine the internal state of a system just by looking at the outputs. That has been true since the 1960s. Initially coming out of industrial control systems when machines and industrial plants became too large for single humans to be able to understand the whole thing. And when actually put science and math behind this. All the more modern definitions, like if you can't ask new questions on the fly, if it's not observability, or if it's if you can only determine that something is broken and not why something is broken, it's not observability. All of those more functional definitions flow from the original scientific definition. And I would argue somewhat strongly that unless someone is willing to give you the real hard scientific underlyings, maybe what they have on offer is not quite as good as what other people might have on offer, to be very blunt about this point. So, if you look at how humans have dealt with data, we as a species have always followed the precise same optimization path ever since we have had written records. So it's not a case of, oh, there's a person and they're talking about observability and everything and blah, 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 blah. It is a case of actually, there is a paper trail throughout the literal thousands of years of written human history that this is an optimization path which makes sense, which has been validated again and again and again and again. So, you start, you do something, and it is worthwhile to persist a record of the thing. And humans always started with the full story. This and that king had this and that many bushels of wheat and this many cows, and the weather was nice, and we had this food, and we sang those songs. You write down everything. As you keep doing this more, as it keeps being worthwhile, this becomes too expensive. So people always have started extracting key events. The classic example are logs, which come from the logbook, where on the ship you threw a log overboard and you counted the knots and you knew your speed in knots, and you knew where on the high seas you were. And if you lost the book or if you did it wrong, very easy, you simply starved and died. Very, very easy. Over time they started putting other information in, like when did they clear what cargo did they take on, who got paid, all of those things. And from an informational perspective, the logbook was everything which mattered about this ship for years and decades. The whole raison d'etre of that book, from the information, like knowing about it, was within this one single thing. But as you keep doing this more, as it still stays worthwhile, this becomes too expensive yet again. And every single time humans have done the same thing, they have put information into the purest form which we as a species know of, numbers. Numbers are great. You can do math on them, you can do large-scale statistical analysis, you can store them really easy and really simply, but you also lose information. If I now tell you 42, what do I mean? Are there 42 printers, or were there 42 burgers in the boxes? You don't know. We necessarily got rid of data about the data, we lost information on purpose. So we need to put some information back onto our data to actually make sense of it. What are those 42? And this is what we call metadata, where we put data onto our data. Short excursion, every single established industry on Earth which currently exists is metrics first, is numbers first. If you go to your bank, you don't want to know about what the teller had for lunch. You just want to know the number in your account and you go. Easy. If you get a bill from your water treatment plant or from your water supply or whatever, you just see the number of how much you consumed. Maybe you have 2 different charges or whatever, maybe also wastewater, whatever. And you know the number what you need to wire to the number of the account. It's all numbers. By extension, I'm arguing that most of IT, with the exception of internet service providers, because they hit those scaling limits like 30 years ago, and the hyperscalers, most IT operations as of today are not mature, because most of us tend to be logs first. And I very, very strongly believe that this is not the sweet spot of data cost versus data usefulness. So, also to talk about the metadata, from an informational theoretical perspective, the sweet spot in the generic case for storing data is key value pairs. Where you have one, if I now say host Richie, speaker Pavel, you don't know what is what. This is what you traditionally call tags and tag clouds and all of that stuff. It really is not, the information is not very useful. Key value pairs are the sweet spot of data cost versus data preciseness, because if I now say host Pavel and speaker Richie, you don't need to rely on the right ordering or anything, you know precisely what is meant. All of what I just talked about is accepted as fact within the math and scientific industries or societies or whatever. And also this is something which Google knew when they started building this weird thing which we now call a search engine. When Google started in the 90s, one of the main things which allowed them to scale as much and to be as successful and to be as cost efficient was Borg, which we now know as the open source re-implementation of Borg, and that is Kubernetes. But also they needed something to actually understand all of those systems and all the additionally broken out complexity, where previously you had nicer containments or older containments of packages of complexities. And this is why they had BorgMon, to monitor Borg. And yes, there is the play on work on Borg and being a lot of the same thing and centrally and BorgMon, blah, 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 like the whole thing, yes, this is like, that's where it's coming from. And BorgMon these days, you have the open source re-implementation of BorgMon, that's Prometheus. Everything within cloud native, or most everything, but almost everything within cloud native will be label based in some way or form, and it will be metrics first. If you get your data out of Kubernetes, what do you get? Kubestate metrics, it's all numbers. And you get them with proper labels, key value pairs. If you do your management of the Kubernetes, yes, this is all key value pairs. Like, this is essential to the success of Google, and it's essential to the very existence of cloud native technologies and by extension CNCF. We literally wouldn't be here if that wasn't super impactful. Still, I'm driving down this point really, really hard because, again, a lot of people don't like hearing this, oh, I'm still on logs, this is not the best way. Anyway, let's walk back to logs to some extent. Let's walk this efficiency chain backwards. Usually when you have logs, you have one of two extremes. Either you have full text indexing, or you have data lakes. Where data lakes are just a euphemism for keeping your storage vendor happy and just buying more storage. And even if you have a good data science team, you're just dragging everyone down because you're artificially increasing the size of the haystacks in which your needles live. And even if you have a good handle on stuff, and even if you would be able to do proper analysis, you still need to go through endless amounts of data, and it just becomes more. And do you want to be the person who takes like 3 days to sit down and say, we can get rid of this data, and I vouch for this with my name and with my continued employment at this company that we can delete all of this? No, it's way easier to just buy more storage. The other extreme, again, is full text indexing. And it's super impressive technology. If you look at this like 20 years ago, early aughts, the overhead for the full text index was roughly 20x. These days we are down to roughly 1.7x. Not we, but like others in the market. So this is super impressive technology. It's really, really far advanced. But you pay for this. You pay in additional compute, in additional network transmission, in additional storage, in additional RAM, in licensing fees. When you read it out, you pay for the compute and the storage and the transmit and the everything. Yet again, you pay extra every single time you do anything on the data. Some people realize this, and now they have like extra data which is not fully indexed, and then you're basically at some variant of the data lake house, which is like worst of all worlds combined, but whatever. The point I'm trying to make here is this. For the vast majority of your data, you're never going to search for it. You're never going to search for a or the. Very likely not even just error as its own. You will always have something else you're searching for. And this is why we have things which are, again, label first. Using the same approach from Kubernetes, from Prometheus, from etcd, from all the other things, put proper labels onto stuff. This is what we now have with Loki, where you actually do put labels onto your log data, and you can jump into your data with a starting point of, I know it is this and that deployment, that software version, this cluster, whatever. You always have some starting point. You almost never need to do a real full text search. Yes, you can do it, and like it's reasonably quick, but it's not a happy path. And it got a lot better with like version 3. So if you only tried this like half a year ago, try it again. It's much better now with like 3% extra cost in storage. But that's not the point. The point is, if you do it, if you go through labels, I've seen examples where people literally cut down the search space by an order of magnitude of order of magnitudes. Because with just like 3 or 5 labels, you really, you carve out so much from your total search space. You can do much deeper analysis and much richer analysis on your data and transformations and getting the data out on this reduced subset of data once it comes back. Now all of this sounds great, but you have a problem. Your data might be fully structured. Your log data might be completely unstructured. It might be partially structured in either the wrong or the right way, or in the partially wrong way. Usually never the completely right way, but it doesn't matter. There is something called Promtail where you can massage the data as it comes in. Where you can do full, like you can do substring matching, you can do regex, you can introspect all of your data as it comes in. You can attach and you can detach labels as you please. You can rewrite them, you can do whatever. So you can actually massage the data as it comes in and improve it, and also learn over time to improve it even more. And following, if we follow the internet model of putting all the intelligence to the edge and keeping the core as stupid and high efficiency and high effectiveness as possible and high speed as possible, or if we use cloud native terminology, we scale the workload horizontally. Same difference in this case. Promtail lives very near to your actual workloads. So no matter how much data is coming into Loki, it doesn't matter from a scaling perspective, because the thing which does the heavy lifting of actually analyzing and recasting and adding and removing stuff and everything lives close to your workloads. Super nice, super robust thing. But also, to my earlier point, logs are not where you want to end up long term. Prometheus has something which is called recording rules, where you basically run queries against your data, and you store the result of those queries back into Prometheus. So if you have this one super heavy query which you run often or not, or if you have that one query which the dashboard depends on, in case of outage 1,000 people stampede to the same dashboard and just bring, like, really put load onto your systems. This is a good example for something where you want to be using recording rules, where you basically run the analysis ongoing, store it back into your database, and then directly access the pre-computed data within your Prometheus. Loki has something similar, but we have recording rules in Loki, and you can basically turn whatever query you can run in Loki into a metric. If you ever used Loki, you'll not only see with your result set like all the results of the log lines, you'll also up top see a bar chart and a graph of how many hits did I have at what time. So you don't sit there with pen and paper or VI or Emacs or Notepad++ or what have you and figure out which 5-minute slice did I have the spike in errors in. you immediately see this visually with every single query you run for free, basically. Of course, we have the data anyway, so you can just show it. But you can also persist this data into the metrics backend. And now what you can do is the following. You can go to your developers, or if you're a developer yourself, you can do it yourself, and you see, okay, there is 2 graphs, and they look precisely the same. One is based on the raw log data, and one is based on the recording rule where we extracted the metrics and just stored them back. And the one thing is maybe taking 200 milliseconds to run and return, and the other thing is taking maybe 6 milliseconds. And over time and over more people and over everything, this adds up. But also what you can now do is a week, a month, a quarter later, depending on internal dynamics and politics, you return and you say, hey, look, I have those 3 graphs. This is based on the, you go there with like 2 graphs and tell them where you have this printf, this debug statement, this whatever, can you please also put a counter? And just increase a number and put this into the storage backend, into metric storage directly. And after a week, a month, a quarter later, you go back there and you are like, okay, I have 3 graphs now. This is based on the raw data, this is based on recording rules, based on logs, and this is directly the counter. Could you please get rid of this one printf debug statement, whatever? And you enable yourself and others in the company or your hacker space or wherever you try to use this, you enable everyone to move off of logs into a more metrics forward world with the full confidence that you're not losing any data which they depend on. It's not this case of, oh, we need to plan this one big cut over and we need to, like, at this time you don't get the data anymore and you don't even know if the new data is any good and all of those things, and if it breaks it's your problem, but if it succeeds it's my success, so haha on you. You don't have this. You have the emotional safety with everyone involved that yes, they can just switch over because they literally see that the old and the new is the same. So walking back more to the full story thing in the optimization chain, traces. I talked to Google in 2017 or 18 about potentially merging open metrics into open census or with open census. Didn't work out for a lot of good reasons. Now open tracing and open census merged into open telemetry. But back then I had this conversation with them. I told them I want to create something where we have an actual label-based standard for metrics. This is now open metrics and the primary thing for Prometheus and everything. And they were like, yep, makes sense. And I told them I want to have the same for my logs. And they were like, yep, makes sense. And this is what we have today with Loki. And to be clear, I'm not claiming I'm the only person who worked on Loki or anything or thought of the thing, but this was clear years and years and years ago. And then I told them I want to have the same for traces. And the Google engineers told me, no, searching for traces does not scale. So when Google tells you that searching for something doesn't scale, they probably did the math. So what is the problem? The problem is this. All the AI hype notwithstanding, machines cannot think. They do not have knowledge, they cannot reason, they do not have wisdom. Anyone who claims that they do is A, wrong, and B, trying to sell you something. The thing is, machines are really good at doing doing the same thing over and over again without getting tired, without getting bored. So machines are good at large-scale statistical analysis. They are good at finding correlations. They are good at pattern matching, at outlier detection, all of those things. So if you want to have automated analysis of your traces and search through your traces, you need to, again, artificially increase the size of the haystack in which your needles live. And this is not good, because you need to increase and increase and increase the amount of metadata which you do attach to your traces. There are solutions which are well engineered, where you put as much metadata onto your traces as you possibly can, but you have trade-offs, like for example, only 3 days data retention or heavy sampling or other things, which make your life actually harder. Like you have an Easter weekend and you don't have the traces from the last Friday anymore. Yay. This is not great. So There is a different way, and this is what Google did. This is what they installed and put into OpenMetrics, which is now in Prometheus and in Grafana and in Loki. It's making its way into OpenTelemetry and a bunch of other things. Exemplars are IDs for traces. Following the OpenMetrics spec, it's just WC3 IDs for spans and or traces. And now I can jump into my traces from my logs, from my metrics. I have this and that high latency bucket, and there is a metric attached to it, a metric ID, an exemplar attached to it, and I can use this. I can jump directly into my trace storage, and not only do I have this for 2 weeks, not only do I not have sampling, so I don't have this game of clicking on the thing and maybe it's gone, and maybe it's not gone, and have like a chance of 1 in 100 that it's not gone or whatever. No, I actually know the data is there. But not only this, I am leveraging this more distilled data in my key events, in my numbers, in my logs, in my metrics, into like someone already did the work. They did the hard work of condensing this information along somewhat meaningful axis for the business, for the whatever. And I can jump from this and that high latency bucket into my trace. From this and that HTTP 500 into my trace. So I know if I see a small cross in my graph and I click on it in my histogram, I know I'm going to be in a trace which A is still there, and B, which is about a slow execution of this and that query, or about this and that server error or what have you. So I don't need to play this game of clicking on a thing and oh, it's gone, and I click on the next thing and I spend 20 minutes self-onboarding myself onto this one trace and trying to figure it out and then realizing, oh no, that's actually the wrong one. I know it is there, and I know what is in there. That the thing which I'm looking for, the error state which I'm trying to figure out why it happened, is within this trace. Again, this goes back a lot to emotional security and to safety, and just having more confidence. Of course, you can move at a higher speed if you know what to expect and you have high confidence that the thing you want to happen is actually happening for you, and not having to play this game against the machine and try and see what explodes this time. There's another thing which I need to talk about when it's about the full story of things, and that's profiles. Profiles tend, or maybe let me explain profiles, of course this is not as well known as the rest. Profiles, basically I look at a program and I see how much CPU, how much RAM did I spend in what functions of what program. I don't do this once, I don't do this twice, I don't do this 100 times, I do this a lot. And I start and basically I don't stop. And this is what we call continuous profiling. And over time, I see changes across all of my different clusters, all of my deployments, all of my whatever. I see this and that function uses this and that much CPU, and maybe it shouldn't. Or if I have this one workload and I have some memory leaks and memory usage climbs up over the days and weeks, I see which part of the code base keeps ballooning and which keeps growing in RAM size. So I know where to look for that thing. Or if the killer comes and it just kills my, just a second. If the killer comes and it kills my workload, and I saw this and that RAM usage balloon over here, I know where it came from. That's continuous profiling. And here's a question. So the question is if there's a difference between tracing and continuous profiling, and yes, a lot. The historic definition, pre-cloud native of tracing was and you're right, I should have explained traces as well, sorry. Like if you use GDB or something on the command line, you could like have your stops and everything. You could trace through the program how the execution went. This is the normal, this is a traditional trace. A distributed trace goes further. It actually traces through all the different microservices and everything, ideally one request. Like that's the ideal state. You don't always have proper context propagation. Of course, you need to know not only this is user X and order Y, you need to know this is precisely this one request of that person. Like they click on something in the web shop and it's being put into the thing and this counter goes up and blah, 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 blah. How did this one request originated by a user or by a machine or by whatever make its path through all my microservices and all my infrastructure, and where did it end up? And the ability to both look at the way it took through all the microservices, and also to introspect within all the different microservices or monoliths, doesn't matter, how the execution actually went, what parts of the code did this one specific thing touch. That is a trace. So a trace is basically about one single transaction which you follow throughout your complete infrastructure. I'm getting it. So for the trace, you also see how long something took, yes. But again, this is specific to one single execution of whatever, or one single request, or what have you. Continuous profiling, on the other hand, doesn't have any knowledge of any single request. It just looks at one program, and no matter if you have one single request come through or 10 million, you get the large-scale statistics about what happens within your code as it is being executed, as not one request comes in with the trace, but hundreds of thousands, tens of billions of requests. That's a very fundamental difference. Traces look at one specific thing, and continuous profiling looks at a lot of things, but not in a very detailed manner. But yes, you're right, both of them tell you something about how long something took. To make it even more complicated, even metrics with histograms tell you about how long something took with yet another vantage point into your data. And all of those are valid, and it depends a little bit on what you're trying to do. So as a specific example of a success with, or to finish the other thought first, there is a good reason why we as Grafana chose to do metrics, logs, traces, profiles in this order, because we strongly believe that A, this derives the most value or creates the most value for the user in this order, but also it just follows a progression path of I need this for my firefighting to I can do cost engineering. And in particular, continuous profiling tends to be more on the cost optimization side. You can absolutely use it for firefighting and debugging, but it tends to be more on the optimization side. At Grafana, we have an internal system of hackathons where every 3 times per year we get a whole week and we can do whatever we want. Like, not completely, but we can work on whatever we want, is maybe the more precise terminology. The only real condition is at the end of that time we have to record a 5-minute video and upload it, and then there's like voting and everything, and we have a winner and blah 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 blah. But the only really hard requirement is we have to have this 5-minute video at the end. When profiling was still relatively new within Grafana, and we didn't even publicly talk about having solutions or anything, one of us wanted to understand and learn profiling. What he did was the following. He looked at all our Kubernetes clusters and just ran the statistics on what workloads do we run how often. And the second most used workload which we had at that time happened to be a code base which he was familiar with. So he was like, okay, let's try this one because I just am familiar with the code and it makes it easier to learn profiling. So we had string handling, obviously in some way and form in this code base. And it was like textbook Go. Really precisely as according to how you learn it, how you should do concatenation. Really nice, really clean, completely unoptimized. But this was fine, because this code path is almost never taken. Famous last words. Turns out this code path was taken 3 times for every single execution of this binary. Or not execution of the binary, every single request which went through the binary went through this code path 3 times. He found this on, I'm not quite certain it was Tuesday or Wednesday. And then, full transparency, we took longer than the week. We took like 2 or 3 weeks to fully validate and do all the testing and everything. But long story short, he literally just copy and pasted from somewhere else in the code base, more optimized concatenation of strings into the other place. And he saved a medium amount of 5 figures per month in computation cost across all our clusters with one single code change of one single text concatenation. So this is obviously an extreme example, but it is a real example which I'm allowed to talk about. There's others which maybe not. The thing here is you can get insane benefits and improvements in your costing structure with profiling. I'm not saying it will always be the case, far from it, and once you're done with all the low-hanging fruit, it's going to get harder. But this is part of what makes this so successful and so impactful. I'm going to wait again, because A, if anyone has any questions, or B, I can just continue on this journey. I'm also taking this chance to take a picture of the audience, so if you don't want to be on a picture and on social media later, you need to hide your faces now. Thank you. So all of this sounds nice, but how do you get to implement this? Because everything which I just talked about, okay, cool, whatever. Unless you get to implement this and unless you find allies across your org, it won't work. So, and we are deep again in the philosophical parts of the thing and also in the social aspects of stuff. Of course, humans tend to be afraid of change. Just a fact. So how can you actually get through a little bit of the resistance? There's a few ways. One of them is, for example, I mean, you always need to show success and you need to basically make people envious of your success. Or if it's upper management, like give you more resources to push you and to continue the success. But on a very fundamental level, unless you've shown success, which others want to replicate, you will not have a lot of co-workers who want to go this journey with you. They're going to try to block you and just sit it out, and at some point you're going to go away and they can keep doing their own stuff. Great. Or not. So, one thing which, for example, can be super impactful is when you start building out your small pocket of stuff, find whatever internal mechanism you have of disseminating information to others and just talk in the lunch and learn or send the email newsletter or whatever. Once you've done this initial thing, usually you find 2 or 3 people who are like, oh, I find this interesting, can I learn more? And then you can start a dynamic where in the next lunch and learn or in 2 or whatever, you actually put this other person on a pedestal and you'd like to support them and everything, but you show their success. And you act not as just one person, you act as more of a team and more people across the org. Sounds abstract, I know. You also have to take the management structure into account. Upper management basically wants to have 2 things. A is the execution of strategy, and B for people to just stop fighting. The strategy which people are having or companies are having is usually digital transformation towards cloud-native technologies while maintaining cost control, open parentheses, AI, close parentheses. Like that's roughly the strategy of pretty much every company on earth at the moment. I'm oversimplifying, but it's not completely wrong. The point is, once you start showing more success, or no, the thing about the middle management, and I know we have managers in the room, so don't shoot me for saying this, but the main use of a management structure is to push down decisions and information and to filter information up, selecting and biasing for the best and for the worst of updates. There's more to it, yes, and also they approve PTO, but this is fundamentally the function of the management structure. So all of a sudden, senior management sees a few pockets delivering a little bit more and fighting a little bit less. And I'm going to give more examples because I realized I did this the wrong way around, but whatever. The most extreme example which I know about is JPMC. I can talk about them, they're a reference customer. And they had a few teams who were tasked with figuring this cloud native stuff out. And one of the teams chose to work with us. And he just kept doing this thing. He just kept showing success and kept sending reports and updates based on Grafana. And it started to blossom from there. All of a sudden, it wasn't only his manager who wanted to have the update. Neil was asked to also send updates to his manager, and so on and so forth. And at some point, the executive assistant of the CTO of JPMC reached out to him and was like, hey, next Friday afternoon, you have half an hour with the CTO. JPMC is not a small company, it is a big thing. So we helped him and like polished the thing and everything. And he did this presentation of his progress and what he did and how he put the monitoring in place to be able to actually understand what was happening and everything. And like in a bad movie, but Niels told me the story himself, as he was getting up and getting ready to leave the room, the CTO was like, oh, by the way, we now have a sure fix every second week, Friday afternoon, half an hour. So he has this sure fix. And one of the most strongest drivers of humans kicks into place, this desire and this raw greed and envy of why is Neil having this half hour every second week and why don't I have this? Well, he showed success, you didn't, very easy. And within 8 months he got promoted twice and is now leading the whole thing in across JPMC. It's an extreme example, a very extreme example, but it is a valid example where if you do the things and if you show the business value of what you're trying to do, not just be a cost center and not just be the annoying person from tech who wants to have new things all the time or who wants to raise a concern or whatever, but actually start showing business value and start showing value to people who have their own personal budgets. That's one of those truisms. Once you start showing value to someone who has their own personal budget, you're never going to go away again. You disagree? No, I mean, okay, whatever. Well, okay. The thing, so more ways to play this game. Again, have your dashboards and everything, yes. Try and send reports based on this. In full transparency, this is really easy with the commercial stuff, and it is harder with the open source stuff, but I've built this before even joining Grafana Labs based on the open source, so you can absolutely do this. Send out reports. I used to be the person who had to prepare the all-hands slides for the internal engineering of Grafana every second week, and asking people why, SLI, SLO, SLA, yes, no? Okay, so SLIs, service level indicator, what you measure. SLO, service level objective, what you measure. Service level objective, SLA, service level agreement, what you have to hit. Usually internally you run on SLOs, because SLAs are usually when you have to pay third parties for breach of contract or something, so you have a little bit of a safety buffer between the SLO and the SLA. If you're more from the management or finance side of things, KPIs are the fundamentally same concept. They just mesh all three of those concepts into one, versus Google, who coined the terms SLI, SLO, SLA, and clearly delineated those three aspects of the whole shebang. So Grafana internally runs on SLOs. Of course, again, we want to have some buffer, so we don't have to pay third parties, obvious. And it was like pulling teeth trying to get people to tell me why something was broken or what they wanted to do to change it or whatever. And then we started sending out a weekly report. Every Monday morning, European time, this email went out. And completely changed the whole dynamic of the whole thing. It wasn't me running after them, it was them coming to me and telling me, hey, this and that is the reason, and we're doing this. It even went as far as people contacting me the Thursday or Friday before that week, before the report went out, and told me, okay, we expect to be out of SLO based on this and that, and this is what we're going to do against it. It completely flipped the thing. I don't know who of you here in the room have kids, but there is a really, really old trick. It's not me saying you have to go to bed. It's the clock saying you have to go to bed. Along similar lines, it's not me saying your service level is shit. It's the clock saying your service level is shit. The point here is I took myself out of the whole equation completely. I wasn't the evil person who ran after people and annoyed them all the time. This email goes out. If it's a good week, a bad week, it doesn't matter. It always goes out. And this really, again, changed the whole dynamic, and it showed a change which management is literally designed to detect and forward upwards. So the obvious question in upper management is, who did that? Can we replicate the success? Can we have more success? Of course, success is nice. And also it stopped a lot of the fighting. Of course, you don't have to, oh, you did the thing and I found this here. No, everyone gets the same information at the precise same time. You can't claim, oh, I didn't know. No, you got the email. And to be very blunt about this, what we do internally, every single engineer gets this email. The complete management structure in engineering gets this email. All of senior leadership gets this email. And key stakeholders across the org, even in sales and such, get this email. So everyone knows what's up, no matter if it's an awesome week or a bad week. This went as far as me having on all hands call twice already, have to tell people they need to be more aggressive in pushing features and in running deployments and everything, because we kept being within SLO across all of Grafana for weeks and months at a time. And if you're never breaking your SLO, you're not being aggressive enough. You need to actually push the boundaries and spend the error budget and do more deployments, more feature velocity, whatever your thing is, but you need to actually really speed up if you always hit your SLO. Just checking the time. So we are like at roughly 10 minutes, so if there's any questions, or I can finalize with a few points and then 5 minutes? Okay. Any questions? No. So the question is if our main product is continuous profiling. Speaking as Grafana Labs, no. The main thing is visualization, and then you have databases for metrics, logs, and traces, and profiling. And then more recently you have all of the and there, I don't call it AI, I call it ML, but like a more respectful and deliberate approach in actually applying a few of those technologies that actually work, like good summaries for incidents and all of those things. We also have other things like on-call handling and incident management, and it's a whole bunch of stuff. Any other questions? Okay, then I'm going to say one final thing, which also has not been implemented here at Prusa yet. Monitors. Get a bunch of monitors of old TVs, a handful of Raspberry Pis, it does not matter. Showcase your work. In the hallways, in the kitchen, ideally at the elevator where your C-level and your boss's boss is sitting, put a monitor and show graphs of what is happening. This has so many benefits. It is insane. You get to set the story. You get to decide what is on those things. So you can literally, if that one thing doesn't work well for you, I'm just trying to be helpful. I just put up a new dashboard and all the company sees that your service is shit. Not my problem. So that's part of it. But also a more positive note. Oftentimes you'll see this where senior management needs to take this guest of honor and take them through the halls and explain what the company does, and they don't know half of what you're even doing. And they're desperate for some shiny, for some, I have a nice thing. They are desperate to just have a talking piece they can just have a conversation about. I've seen this so often where people, senior management, just stop next to the monitor and just, yeah, and we did this and that and that thing, and you're sitting there and you get what actually is happening, and you're like, this is all wrong, but they're happy. It's fine, they're happy, and they take the thing which you like. Also, I did this at a previous company where the two of us worked. I had the budget for the monitors. So unless you were at X% of your services that your team was responsible for and had them in Prometheus and in Grafana, you just didn't get any monitors. So you just didn't get the shiny. Fix your stuff and then approach me, and then you get the shiny. It is insane how powerful this is. And also put a small sticker at the back with, in case of issues, please call XYZ or send email to whatever, or Slack or whatever. On the face of it, yes, you're being helpful and you're telling people if something is wrong, yes. But also everyone who wants to have the shiny, be it a potential ally or be it the CEO and founder. They see your name on the thing, or your team's name, or your whatever, as, that's the person who did the nice thing. I also want to have nice thing. I need to talk to person. Thank you very much.
We do actually have one more question on Slido. Yeah. Last one and first one. Do you remember Hotsenic RRD tool? Did you like it? Wasn't the word easier? Just for fun question.
I don't know Hotsenic. I know RRD. No. So the question is basically, did I prefer the old style of monitoring? And the clear answer is no. The reason is this. If any one of you has used Zabbix before, like that's used to be best in class before Prometheus came around, you could do quite a little bit of math on your data, but you were still limited, and it was a very, very static, and you needed to do the things. Also, if you want to have a conversation, feel free to leave. The thing about literally all the old style monitoring which we used to have as an industry before Prometheus came around was fundamentally tying, and I'm just talking metrics here, but same difference for the others. It was tying your analysis down into a very, very static way. RRD tool in particular, you could draw one single thing, one single graph, and you have all this wealth of data, and you throw it in the trash. Basically, you render one single graph, and that's it. With Prometheus and with modern observability, you have the raw data, you can do math on your data, you can do statistical analysis on your data, you can use your data into 20 different things which you don't even know you would ever be asking, and 3 years later, you can ask the question you never even thought you might have, you didn't even have a concept of that question, because you can work with the raw data. It is so much better.
Okay. Can you hear me? Yeah. We are waiting. And I'm sweating. It's pretty hot in here. Now. Yes. That was almost spot on. I would like to thanks G2 for sponsoring this meetup. They can help you with your cloud issues or on-premise issues, and also then can help you with you being here and because they are sponsoring this meetup. So shout out for G2, please. Okay, now the interesting part, obviously. We have still some catering left. Take your food, take drinks, enjoy. We have 10 minutes break, and we'll continue with next talk. ask you kindly to sit down, please. We have 1 minute to sit down. Excuse me. We are about to start. Networking will be later. Please sit down. Začínám, už se po Japonsku, prosím tě.
Which mic should I use?
Hmm?
Which mic should I use?
This one.
Are they the same? Or check, check, check. Check, check. Check, check. Prop, prop.
Are we sitting down?
Exactly what it should do. So, hello everyone. My name is Basti Schubert. I'm a senior solutions engineer with Grafana Labs. And when I don't work at Grafana Labs, I try to run some infrastructure for the Munich Fire Brigade. We're the largest fire brigade in Germany that's running by volunteers for roughly 1,500 folks. I do the IT there and infrastructure stuff. And for those of you who know the FOSDEM conference, Richie and me, we're part of the FOSDEM infrastructure team. We are the infrastructure team. And we try to make FOSDEM less shitty by providing infrastructure that should just basically work. And yeah, that's why I'm going to tell you a bit about how you can use cloud native technology to look into older systems like low-level network information or other things that you might have sitting in your data center. Just a quick show of hands. I think Grafana is known by everyone. Does everyone know what a server is? Or a switch? Yeah, nowadays you can have folks that are so cloud native they don't understand what a network is. So that's why I'm asking. When you now go to such an AWS event, you're instantly brainwashed by the word AI, for example. So you don't recognize that there's something behind that powers that AI. And we're gonna have some screenshots here as well, and maybe I'm gonna have a good demo for that as well, if the demo gods are good with me today. So, what is SNMP? Who of you has heard of SNMP before reading what I'm gonna talk about today? Okay, great. So SNMP, what I say, it's simply not my problem, but basically it's not. It's a management network, management protocol that's used basically for network devices and everything that has the ability to work on networks. It allows you to read and write configuration information, and if you want to take photos, that's great, but I will also, if you want, I can just send a PDF if you are interested in that. SNMP is about as old as I am. No, it's a bit younger than me. It's roughly 40 years now. And when it was designed back 40 years ago, it was completely lacking what we call security nowadays, because SNMP is also security is not my problem, because in the first iterations of SNMP version 1 and 2, you barely had no security. You had a string that you could guess, like this is called what the community string, But if you were into wiretapping, you would easily just sniff that information, and then you were all in and could then manipulate machines and things. So it's not very, very good from a security point of view. With version 3, that was added very, very, very late. Encryption was added, and we get some sort of security with proper authentication framework behind that. So, yeah. The good thing about SNMP is it's so old, most of the vendors know it and have agreed on one standard, which is not that common nowadays, because everyone puts out, hey, I have this API, you have Swagger, go figure out yourself how to get data from my system. And with SNMP, you have something called MIP, it's a management information base, which most vendors agreed on, and if they did not agree on something in there, they just created their own MIP file where they defined the data, where you get the data structure like in a Swagger or an open API definition, you get that for infrastructure as well. So that's why SNMP is quite a kind of cool and still relevant today. If you couldn't follow me now, I have a tip mentioning AI the first time and hopefully the last time today. There's this ChatGPT could also explain that, but I think when I do it in a person, as a person that is working with that on a day-to-day basis, I think it's more detailed what I'm going to talk about. So how do I get in touch with SNMP? Typically, you use it in like a network environment. Any one of you running a home network, whether you have routers or switches or anything you're uplink that you're monitoring, you do that with SNMP. Any one of you? Yeah. How are you doing that? You're nodding. Prometheus. Yes. You want to meet 2/3 of the Prometheus SNMP maintainers? Basically, last week I got promoted to maintainer of the SNMP exporter for the Prometheus. Yeah. Yeah. You have it with bare metal service, which we have when we run at FOSDEM. FOSDEM is happening in a university in Brussels, and we have a campus there, and we can't rely on any cloud connections, so we do everything there in infrastructure. We have our own infrastructure that we can use and leverage some fibers that are there that we can just attach to. But basically, we have bare metal service. We have also UPS there for power supply. If there's an outage or any transient problems in the power, we can measure that. We have power distribution units. Like Richie was saying, he built a data center before. I don't know if you've had that in your talk track. I think so. No, his last job was building a data center. My job was with him monitoring that data center. So yeah, you can monitor quite a lot of stuff, like storage systems, printers, whatever you like. There's some office IT that's just checking if there's enough paper left, or if there's something stuck in the printer, or if the toner is yet to be replaced. You can all do that with SNMP without having to deal with too many different standards. Just use it. It's a printer. SNMP knows what's a printer, and just go for it. So what is the SNMP exporter? Quick show of hands. Who of you knows how the Prometheus exposition format looks like? Okay. I'm going to show you how Prometheus metrics look on the wire, and then you get maybe an understanding what Richard said about open metrics and the things. Then you can see them as a living object. Thing is, SNMP data is some sort of hierarchical data that is organized by an ISO root tree and then goes down to a vendor or a specific implementation. Maybe you have host metrics or interface stats, and it's all done in a hierarchical way. Prometheus, on the other side, being cloud native and scalable till the end of time, uses an n-dimensional metrics for organizing data, which is done through labels that are applied to a metric. So the SNMP exporter is some sort of the wizard that's sitting in between Prometheus and the SNMP devices and does all the mapping between both of those data structures, between the hierarchical data and then the metrics. And when you have the access to the MIP files, the MIBs, you can easily create a translation for them, for the Prometheus SNMP exporter, that will just take the vendor supplied MIP information and create a mapping to Prometheus. Now the vendor pitch. As I work for Grafana, the SNMP exporter exists as a standalone binary that you can use, but you can also use it with our Grafana packaging. We have an agent that's called Alloy that also vendors in the SNMP exporter. So if you're interested in doing things and having it, if you're a contracted customer, getting support for that, maybe you give Alloy a try. So for example today, what I'm going to walk you through, this is what our FOSDEM network stack looks like. We got rid of Cisco. Almost everything was replaced this year from Cisco. We had 14-year-old Cisco switches and replaced them with 12-year-old Arista switches because they're cheap. This is, I think, 48 times 10 gig and 4 times 40 gigs. Costs roughly 350 euros, which is okay-ish for the price, for what you get, because they switches already allow you to run Docker on it and things like that, so it's quite nice. And we know that Arista is doing a really great job in being very friendly for administrators and not putting thousands of needed licenses on that to actually monitor those devices. So when we revamped the network stack for this edition of FOSDEM, we bought quite a lot of those things, and we just ripped out from everything from Cisco and said, okay, we want to get started with the monitoring. What do we do now? Oh, yeah, we're using SNMP. We don't have to do anything because the interface metrics still stay the same, because an interface is an interface, regardless if it's Cisco or if it's Arista. It's just an interface. So what does the data look like? And when I was talking about hierarchical data, an interface is like an interface. Hopefully this works. I think it's magic, yeah. The data is organized. It all starts with a dot. It's like the DNS system, but just the other way around. It's from left to right, whereas the DNS is read from right to left. But you start with a dot, and then you have those numbers, and those numbers are being translated to something that we call interfaces. You have a number, you have a table, and you have all those things that then end up in a metric. For example, if you want to know how many octets or data words have been written or have got to that interface, you just look at IF for interface in octets, and if you want to know that, you need to look for that OID on the switch, and the SNMP exporter knows that, knows how to read that, and translate everything from this hierarchical data to the metric. So how does that look like? If I do such a walk, it's called SNMP walk. I'm querying one of our switches. Have that fancy number here. Nobody can read. Maybe some old veteran Unix folks. They just come up with that numbers every night in their dreams, but not me. What you see, you have that number, it ends in 2211, and we get that 2211, and then we have some sort of incrementing number. This is called an index, and we can just basically use that or reuse that data in other queries. So we're just gonna walk through something else. We wanna see how's the speed of that interface. So we're gonna just walk up to the next OID, very cryptic, and we see for interface 1, 2, 3, 4, 5, we see the interface speeds, and this is 10,000 because this is a 10 gigabit interface. So we can get a metric out of that in the next walk. The last time you will see that I'm boring you with an SNMP walk. We do the same. We want to just get the interface name of the switch, which is also presented as a string, and this index. And what you can see here, we can also use alphanumeric information, not just numbers. Because we had numbers here that you might know from metrics, but we are able to pull in alphanumeric information as well. And I'm going to show you that in a minute when we go to the server, when I have an overview where you see that a power supply has failed and you have the complete error message in a metric. Hope everyone can read this, also from the back. What has happened now? We're gonna try to map the information. We have that ISO, blah, 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 blah. integer 1 is the if index. Then we have this number, it's the if name, Ethernet. We have an if desk, that's an if description. This is something that the vendor puts in. If you have Cisco, it probably will put something like GE blah 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 blah, and something that you can't really control, so don't rely on if description. And then we have if alias. This is something that you as someone that controls the switch will set. And you have also other informations. We have taken the if speed, for example. We have the if high speed, and you see some glitches here because if speed shouldn't be used today anymore because it's a very small counter that easily is maxed out around 2.5 gigabits of an interface. After that, the counter will overflow and it will emit the highest possible 32-bit. And just don't use it. Use IF high speed. You get a number that you can rely on. And then we get a basic counter like IFHC out octets. That means this is the high counter. This is a 64 precision bit counter, where you can see how many data packets have traveled through that switch port. And to sum it up, we get a metric, IFHC out octets. It leverages if index from here, puts in the if name from the next one, and the if alias, so I have some meaningful name. And the metric that we got from that port, we pulled that here and represented it as a metric. This is basically how the Prometheus exposition format looks like. Metric name, labels, value, and to be precise, you can also add exemplars as a command, but we're not talking about exemplars today. And we have the next metric, if speed, if high speed, we get that to 10,000, so we are basically just translated some data that's sitting in a 12-year-old switch to a cloud-native monitoring system called Prometheus, and we can now scrape that information and feed it into Prometheus. So what is happening behind the scenes? How do we do those mappings? When we tell Prometheus SNMP exporter, hey, scrape that data, we need to give it a hint how to work on that data, and that's what the generator comes in, that just parses these MIP files and gets some hints from us. We get the hints, for example, for use that if index and look up the alias to do that mapping that we saw before, like this index, map it, map in the alias. And the same we do with if name and if index. This is what we basically do in the included, call it demo or example configuration that comes with SNMP exporter. And we do the same here with the description, name, and so you map in everything. Every label that you want to have mapped in, you can just map it like this with the SNMP generator. And you can also like throw away the if alias metric. We could have easily had a metric called if alias with that information. But as you know, that wouldn't be so useful because you would have duplicate data that you can't really use. You're just gonna tell the SNMP exporter to throw away some metrics that you don't care about because they would just drive cardinality and don't bring any value for your monitoring. So that's what you can also do, and do a lot of translations from one metric to another, but this is more like when you're really into SNMP exporter, then you can do a lot of crazy stuff. So how does it look like in production? And I've just taken one of our Grafana Cloud examples. We have Grafana Cloud where you can use all that stuff, send the data, and we can visualize it for you. This is like a basic dashboard that's showing you from a normal Linux machine what's going on. Linux can also run SNMP agent that you can query, and you get some information like the name of the interface. And can you read that in the back, or is it? It's quite small, yeah. And you get the information like what is that interface, what's the MAC address, and things like that. You can pull that out and then visualize it. Who of you runs your own cloud in your own data center and does not rely on a big cloud service provider or a managed service provider? You're monitoring your infrastructure with the same tools like you're doing with your cloud native? Or are you still using something like Zabbix or so for network monitoring? Give that man a beer. Excellent choice. Yeah. So what we've done with FOSDEM, and I hope you can read that, but I'm gonna walk you through that. As Richie and me share history with working at an internet provider and dealing with switches a lot, and with the problems that can occur in switches that use optical networking and not fixed ports but cages that are use pluggables. We decided to not only take a look at the most common metrics, but also things like, are the fans spinning? Are the plugs, the pluggable things that we can put into the switch, where you have the laser that emits the light for the fiber. You can have all those informations inside Prometheus and then visualized in Grafana to get an understanding, like, is it getting too warm? And you get it from every of those things. You can see the signal levels, how much light you will receive on your side. This is really nice to see if you are leveraging database functions like predict over time, to see has that degraded, or is it degrading too fast, or is my power draw, for example. Usually you use the signal levels for the light that you get on a laser from the collector that's collecting the optical light level. And the power draw, you see the sending side. This is usually when the sending side goes up. Usually some electronics will break anytime soon. We've done that a lot, or seen that a lot, that over the years the pluggables, they just degrade, like every part of electronics degrades over time, and you can easily monitor that. See, okay, I have one of those pluggables that's just taking more and more power, so it will fail anytime soon, and I can replace it during a work day instead of getting up at night and fixing things when you want to sleep. You can easily have a prediction of hey, around 2 weeks or so, and it will die, so just replace it during a workout. Maybe do a proper change for that instead of getting up and rushing through your optics and trying to find something to replace that. You can also get basic information like what are the interface levels, and hopefully I can show that in a minute. What we also see is we have information from the hardware that FOSDEM runs on, like log entries. The power supplies are redundant after I just powered them on. The input power for power supply has been restored. This was basically the first power supply I just put in there, and things like that. This information, which is a log entry from the hardware, can be fetched as a metric and displayed. The metric has a value of 0 or 1, but we can put this information in a label if we want to, which is really nice if you want to have not also log collecting and things from your hardware. You can basically just use SNMP for that. And everything else, I think it's quite self-explanatory. Since we don't have that much money to buy new servers every year, we don't have a GPU, but we could also do GPU monitoring. We use Dell servers, and they emit those information via SNMP as well, the usage of the GPUs. Anyone that uses GPU cluster or sets up GPU clusters nowadays uses the NVIDIA exporters, for example, but you could get this information from SNMP as well. So, let's see if I screw up or not. Yes, the answer is yes. Thanks, okay, thanks, bye. And by the way, if there are any questions, just feel free to shout at me. Don't throw anything at me. And I will try to show you the live status of FOSDEM. Maybe we can start with things like that. We have currently 5 servers sitting somewhere in Brussels, not doing anything. And what we can see is like we have our fleet overview. We've built that on top of SNMP data that we just thrown in there. We've seen those machines. And Pavel and Richie, please forgive me because I ruined their afternoon because I needed to deploy some security fixes today while we were here, and we can get those basic informations without having anything running on the operating system. This is all done by SNMP on machine level, not something that we have to install. We get basic information from what the hardware is, and if we're lucky and I don't screw up, I will be able to just dig into that information here and see the status, if everything's okay, what's the current power draw, how are the fans, how's the CPU temperature, how are the NICs, are they connected or if they're not connected, things like that. We have a RAID that we've created here. We have disks that we use for our Ceph, for our software-defined storage. They're not in a RAID. And I can pull out all that information basically by just what the Dell has put into it there as an MP agent, which is quite nice because it's roughly 2 minutes of work just typing in the correct host name, like this one, and that's it. So I know where I can grab the data, and that's it, because we enrolled everything automatically, so we have password setups and so on. It's all the same for the service. It's not a very high secure system. So roughly took me 10 minutes to have everything in place, including the dashboards and the correct links. The other use case that we have is seeing our network infrastructure. Maybe we see some more around when I created some updates, and when I pushed a bit more on the wire, over the wire. What you can see is that you get a lot of basic information from the chassis of the switch itself. Yeah, CPU temperature, write, whatever. Trident is the chip. Bless you. The chip that is used inside the server, the switch. We have those pluggables, DOM, temperature sensor for Ethernet 50, which is basically the pluggable that I've plugged into port 50. It's at 23 degrees Celsius, for example. And you can see, for example, that the power supplies are getting the best air because of the way we installed the servers. They just take all the fresh air into, so that's the coolest part, and the highest part is obviously CPU, because that's what's heating up the thing. We also get broken down information like RX and TX for every pluggable that we have there, and are able to diagnose issues on our fibers that we have. You have to think of, I don't know how big the campus is, but I think it's roughly 8 or 9 kilometers of fibers that we have. It's not a big deal. Fibers nowadays, we use single mode, they can handle those lengths with no problem, but if there's anything, we are able to see that information, and we can alert on that, and we can have alerts that also take degradation of the fiber line over some time. Power supplies, things like total working. When you used to Prometheus, you could do an easy alert rule, like if total power supplies minus working power supplies greater 0, you have a problem, or you have a power supply that's not working, or more than one. Can easily alert on that data with the cloud native tool set that you're already using. And yeah, last thing, like the power draw that we see. This is where the first round of shit starts. We have different units used here. We have watts and we have milliamps. One could argue they're the same. Yeah, if you're from an electrical engineering standpoint, they're not the same, but most likely if you have a good power factor, they are basically then the same again. But you can see that information, and you can then have alerting on if the power consumption is way out of bounds, or it's just increasing. And you can also get an understanding, for example, if you know what vendor you have, like we have FSCOM and Flex Optics, and you could then, for example, distinguish, hey, we want to buy 500 new switches and 5,000 new optics. Flex Optics is taking whatever 27 milliamps, the others take 32 milliamps, so we're gonna go the route for this vendor because you have to pay for the mains, for the voltage, and in the long term you will save some money. So you can use this information as well as making business decisions. Yeah, everything else is like basic stuff. Yeah, like how's the load. Maybe we get some information on the interfaces. Maybe just set some filters to reduce the noise. Basic information that you are used to from other monitoring systems, as Zabbix or so, is just like what's going on the interface, what are the packet write, what are multicast broadcasts and how much errors do you have. This is basically what you get from any regular monitoring system. Yes? No, we don't use Docker on those aristas because yeah, we have two Prometheus servers, and we have SNMP exporter co-located on those Prometheus servers that are used for scraping the data. Yes?
So how far from the network point of view are these switches from the Prometheus scraper? Because what I see is when the latency is high, SNMP is not very much.
Okay, so the question was how far is it from the scraping service to the SNMP endpoint, and it's a very flat network that we use for out-of-band monitoring. So it's basically on the same network. So there are no hops or anything else between them. There's one basic, very, very dumb unmanaged switch to not interfere with anything that's used for the out-of-band monitoring, and that's where the whole traffic goes over. Yeah. Okay. So why I'm showing you this? Because I still need to find 10 minutes for my talk. No. The thing is that, for example, you have information. Maybe we can see some information here on Ethernet port channel. We have that here now. We have that information here. We've put in. We know it's Ethernet 2. We have the alias that we've just grabbed and said is proxmox02, for example. Maybe I have some sort of backup server, and I want to alert if the network usage is really high, like having outbound traffic or inbound traffic for 99% of the capacity that link has going on for longer than 5 minutes. Maybe I have some ransomware and it's trying to decrypt my stuff, or maybe someone is just sending a lot of mails or whatever. But then you have a server where you don't want alert on that because maybe it's the backup server and it's intended to pull in data as fast as it can to not interrupt classical workloads. So you can use that information to also check or create meaningful alerts that don't wake you up in the night when it's not necessary. When you have, for example, alerting rule that says, okay, 80% of the bandwidth is used through a whole week, just alert me on that. Then you can use an exclude, but don't use that for all of the servers that are, for example, backup, point, my domain, or whatever, to not wake you up. And this is where it really comes in handy, and you get that information. Yeah, you don't have to do anything else to use that information in an alert, because if you have a decent service discovery and decent naming scheme, then this all should work out of the box. Who of you is having a cool naming scheme for everything? And I don't expect anyone to put up a hand, because naming is one of the hardest thing in IT, I think. Check. Okay. So, for the last 5 minutes, what actually is it that when you scrape metrics on a bigger level than we do at FOSDEM for basically 3 core switches, 5 servers, and some edge switches? When you run your own Prometheus, usually you're interested in not to overload the system. Like from one way that you don't want to scrape those machines too much, because the CPUs in those machines are not really meant for pushing telemetry information. They're meant for managing the switches and not for being queried every 5 seconds. Hey, what's the status of that interface? And the Prometheus side also needs to sort data somewhere, and with a high number of switch ports, you have very high cardinality, and that could also overwhelm your monitoring system. To understand what the cardinality drives, we're gonna take a look again at one of our switches that we use for FOSDEM. So if we've looked at it from the front, we look at the back. You know what you see here? You see power supply, another power supply, and 4 fans. That's it. Nothing fancy there. So this is basically what we take into account. We have 52 networking ports, 2 management ports, which for one we can ignore. We have 2 power supplies, 4 fans, and as you've seen before, a shitload of temperature sensors, because everything on those modern switches is connected via I2C bus, and everything that can emit temperature metrics, it will. So I've taken the switch, this Arista switch, and just give it a try. And the first thing I saw, from one switch I got 4,800 metrics. If you would put this in Grafana, one switch a month, 4,800, this is 4.8 times 8 euros, you will end up with a monetary amount. If you do it cheaper or more expensive, you will come up with your own numbers, but you will need to somehow justify the costs that this will bring, because at the end someone needs to pay for that. So that's what you should be aware of. Maybe you don't want to monitor switch ports that are shut off. This could be one of the ideas, but just think of that before you implement it and receive the bill. What actually drives this cardinality? I've taken another shot and did some Prometheus queries on that, and it just, I filtered out the metric names, and what you can see is we have 52 switch ports, but we have 392 upper statuses, because a switch port cannot only have up and down, can have administratively up or down, it can have I'm sorting my brains or whatever. There are 7 different states defined in SNMP a switch port can have. So maybe you want to consolidate that and have not a metric for every upper status, or maybe you just don't care for that because you're just throwing it away. You can have a lot of Ent is environmental stuff that is mapped in. These are basically the sensors that tell you how hot is it in that part of the switch, how hot is it here, how hot is the CPU. All those things go into the Ent physical things, and these are really driving the consumption, because a lot of sensors are nowadays in those switches. Maybe you don't need them because you have proper monitoring for the cooling of your data center, and you say, okay, I don't care for them, I know temperature inlet is okay and the rest I don't care, then just throw that data away. And if admin status, you see this is the same, then it's getting back to some more normal values. There are more than 52 here, because I created a lot of port channels on those machines that will show up as virtual interfaces. That's why we have 76 and not 50 something. So maybe take this information into your account before you start monitoring your network with Prometheus. How do you do that? How do you get started? Basically, just download the SNMP exporter or Alloy or Grafana agent. It will come with a pre-made SNMP YAML that you can use to learn, not use it in production, because you will have to adapt it anyways, because you will bring your own authentication. There's no authentication set in those things. You need to come up with your own SNMP YAML, which can be done with the generator. It's part of the it's not part of the distribution, and you need to build it yourself or use a Docker container. And if you use that, please always use the version that maps to your SNMP exporter that you're using, because there are breaking changes between generator and SNMP exporter. Be aware of that when you do that. And if you want to try that out, please use a modular approach. Maybe you use the default SNMP YAML, and we create your own SNMP YAML or SNMP2 or auths or something like that, and then just use the SNMP exporter with the config file argument that just globs through a directory, like my directory asterisk YAML, for example, to pull in all the things. So you will end up with usually working configs that you can handle better in a Git approach. And if something breaks, it's just usually removing one YAML file instead of going and searching what has happened inside the generator. if you're using Grafana Agent or Alloy, SNMP exporter might be based on another release than your generator. Be aware of that. And because this has happened in a workshop that I had with customers, please always check the versions. Otherwise your config might be bricked, or it will be bricked, because we introduced a lot of new features recently in SNMP exporter, and the generator knows of all of these features and leverage them, and you have still the old version of SNMP exporter that doesn't know anything. It said, got an argument here, I don't want to have an argument today, so I just quit. And if you see that something called scale was introduced recently, maybe it's just one line, then you can remove that manually from the SNMP YAML, but you need to know that, and unless you're a maintainer, you probably don't know that things. So please always choose the version that matches. That being said, there's still some food left, or not? Pavel?
Yeah.
Yeah, there's still some food left.
Well, left on the way.
On the way, on the way. I would call it a wrap. It's not a burrito. If you have any further questions, feel free to approach me. I'm gonna check Slido now.
Yeah.
There is no Slido. Or how do you deal with counters overcome its max value? Ignore, skip abnormal value, or do some other trick? So that's an excellent question that is tied to how Prometheus deals with counter resets. As I've stated before, with that interface speed metric that will just overrun at 2.5 gigabits interfaces, this can happen with any metric that is tied to some sort of associated definition, like 32-bit counter, 16-bit counter. It will overrun at some time, and the counter will reset. And if it's a counter, and you're next, yeah, if it's a counter in Prometheus, we assume a monotonic increase, so it can only go up. If something goes down, we will detect that, or not we, Prometheus will detect it in any Prometheus compatible database, and just take that into account, and will then magically shift the information, and we'll just reattach that and have the constant growth considered when we do calculations. Prometheus does that on counters. There's more.
So this is one of the things which, like, all of Prometheus does this, which makes it really easy. If you lose state or you restart your exporter or your workloads, you can just keep counting up. That's easy. There's one important thing. This is a 64-bit value, and it's a float. So it's a float 64. For preciseness reasons, and this is something which SNMP exporter does out of the box, at 2 to the power of 52, so at 52 bits, you start losing precision within float 64. So at 2 to the power of 52, we actually just reset the counter to 0. But this is also the only example which I, as a Prometheus maintainer, know of from the real world where you actually run into issues with float 64 overrunning. Basically network counters of some way or form on 10 gigabit or quicker interfaces. Everything else you won't run out of counter space, but with this precise thing you can. And this is why for SNMP export, again, we reset at 2 to the power of 52 to retain preciseness in your float.
Thanks, Richie. Yes?
You spent very nice dashboards that you have presented. Are these dashboards available, or is it just that you made it yourself internally? Because like building dashboards is always hard. It's very late.
So the question was if the dashboards are lying around somewhere, and that's a good part. I will just take that information also with our scraping definitions and put them on our FOSDEM infrastructure repository, where we have everything from FOSDEM in open source. Be aware that we don't follow things that are now used with Prometheus from the naming, but you get an understanding, and maybe you just rework the names and how you attach labels, because we follow another approach. Because how long are we using Prometheus SNMP exporter? When did 2015, so there's a lot of tech debt that we have in there. Tech debt, yeah, legacy, it's the same. But maybe I can clean it up, and I will upload it to our FOSDEM infrastructure. It's GitHub/FOSDEM/infrastructure, and I will add them there. But if you want to have them earlier, before I clean them up, just approach me after the talk here, and we find a way to have that. Yeah. There's another question. SNMP trap support. It's an anonymous question, and I don't answer anonymous questions. No, the questions come up quite a lot when I talk to customers. I'm part of the pre-sales team at Grafana, so I'm the one that's trying to sell you something, and I hear that a lot from customers. What about SNMP traps? And as you see in my last slide, it's a wrap, it's a trap. SNMP traps are not reliable. Why should I use them for monitoring? There are several cases where they are okay to use, but most of the use cases are nonsense for SNMP traps. Think of, you have like, do we have some sort of, no, we don't have a UPS here, uninterruptible power supplies. There are some of them, they are not very intelligent, you can't query them. The only thing that they can do is send an SNMP trap, I'm about to die, goodbye, and fire that to the network. This is an okay use case. If I have something that I can actively query at an interval that's okay, maybe 15 seconds, maybe 60 seconds, after 60 seconds I would have that information, hey, this guy's not responding anymore, maybe he's died, and alert on that. So I win 50 seconds, or 60 seconds, or whatever my scrape interval is. This is what SNMP traps can help you with, but on the other side it's unreliable, and it's used in a networking environment, which is also sometimes, no, network is never the problem, we learned that a lot, but if shit hits the fan, you will lose your SNMP traps because they're sent via UDP. There's no way of actually have a reliable transport for that. There are approaches like have a syslog server sitting somewhere next to that device and use something like our syslog uses OMRELP, which is reliable logging protocol within our syslog that can take care of that information. And this is basically what I tell customers. Yeah, you have a SNMP trap D somewhere running near that device, grab that information via to syslog, and then ship that syslog information as a log to your logging stack and alert on the log that's been emitted. But don't rely on it for monitoring. Please use active probing and don't wait for someone to shout at you, I'm dying, that you've never heard before. Because maybe the name is not working and it's not tied to your CMDB because it's a very old and dumb device, you don't have it. You end up with an alert that's not actionable. So I wouldn't bother using SNMP traps anyway, but it's my personal opinion. Okay. So the question is gone. Maybe it comes up in a bit. If any tips for unknown MIPS, go ask your vendor. And I mean this seriously. They are hiding this information. If you want to get some information about your MIPS or your devices, go ask your vendor. If you have a contract, support contract, go and nag them. If not, there are excellent folks like LibreNMS that have put a selection of MIPS on their website in their GitHub repos where you can copy those MIPS over. We don't do that for Prometheus because we actually care about copyright. This is intellectual property of the companies that created that, so we don't just take them and throw them into our repo. But we suggest if you can't find the MIP because your vendor didn't supply it, or you can't find it because the website is really crappy, like Schneider Electric is horror to find something there, then maybe have a look at what LibreNMS does. They have a really great storage of MIPS, or also look up something like Observium or Circuitor.fr. They have a lot of MIPS lying around. Yeah. What? What's that? There's an ancient operating system called Debian. I just learned about today. And they have a repository that's not super fun to use. And I learned that the hard way when I tried it with the new service that we brought for FOSDEM this year, and my experience was like, it was, what's MIPS conflicts resolution? Okay. Maybe I can show that here in a live. If you go to, just hang on a second. MIPS are definitions. Anyone can write them, and anyone can choose a naming schema. And there are maybe some glitches in there that you have a problem that you have the same name for a MIP. So what you can do, and use it. Use OID to avoid conflict with blah 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 MIP. Instead of we just want to use the if descript, we hard code the MIP here because we know there are naming conflicts. And this is also in the, this is the example, this is the source code of the example generator YAML. This is how you can avoid running into the wrong MIP tree. Okay, Anonymous is getting hot. MRTG and SNMP. It doesn't rhyme, but in the text before from Richie, in the talk before from Richie, we were talking about the legacy monitoring systems. They had their time, but you're losing a lot of information and context by looking at a single information that you can't really use or expand to the rest of your ecosystem. For example, with the Prometheus metrics, you can easily have like CPU saturation of a process that is tied to the network link that is, maybe you have a 100 megabit link that is completely saturated. Then someone needs to take care of all of that. Your CPU goes up. You can correlate those information, those events. This is nothing that you can do with MRTG. Okay. Are you typing all those questions over there? sitting, the only one sitting at the laptop. Just curious. Can you go in a bit of a detail on how you handle forecast alerting? Switch dies in 2 days. How can you handle the trigger not alerting at 2 a.m. 2 days before? Yeah, that's an excellent question. Maybe I have those alerting rules here as well. Just need to drop the mix. Just a moment. For example, we have that here, SFP, which is small form factor pluggable for anyone who cares. We have those here. We have math, and I'm not a teacher, but it's math that we're using here. We have those metrics that are, you see the optical TX bias current where you can see the actual power levels, and we just have the drift, and then you have an alert with the severity of warning, and with your alert routing you can then decide warning just fires an email and doesn't wake up anyone at night, or maybe info or whatever, and you can do the do your math yourself. We learned it the hard way that this increase in voltage will last for roughly 5 days and then it will be broken. We had a lot of network devices, so we had a lot of data and we could compute things like that. The same with Juniper. Juniper has other things, but you need to know your metrics because there's no common way to determine which of the metrics is specific to a vendor. Arista does a great job. They use the normal entity things, but Juniper or Microtik, for example, use vendor-specific information. But yeah, basically this is what you use here, and you see there's a lot of things going on in the label matching, and a lot of ugly Prometheus queries, PromQL queries, because we were running this also since 2015, and we have slightly different approach on labeling, so that's why you have a lot of joins in here. I hope that answers your questions as well. NetFlow via SNMP. So how does NetFlow work? Not via SNMP. You have to send it somewhere. NetFlow, IPFix, SFlow, you can use, for example, PM, ACTT, and run that. Emit metrics, push them to a Kafka queue, and have a flow exporter to pull the data out and persist it to Prometheus. And please don't try to do that yourself and try to circumvent the Kafka queue. It is really needed in a network where you have a lot of flows. Despite if you're sampling at what rate? 1 trillion samples, then you might not need a Kafka queue, but usually PM ACCT, push it to a Kafka queue, and then read it from the flow exporter and create meaningful Prometheus metrics. Okay,
And that
Mr.
was-
Anonymous, the pizza has arrived. You can't see that here, but we're hungry.
I guess that was all the time we had.
Yeah. Pizza time.
Yes, exactly. It's
That's
pizza
what,
time.
That's what Ninja Turtles say when I was a kid. That was pizza time.
Okay, thank you, Basti. If you if you are interested in the Prusa tour, just catch him in the Prusa t-shirt, and he will give you a tour. Pizza is there, and drink is there. Enjoy.
And anyone else who wants to talk to me or so, just approach me and give me a nudge.